So now that we've been looking at compounds that involve ionic bonding, so if you recall, that's a metal and a nonmetal, metal and a polyatomic, two polyatomics, or a nonmetal and a polyatomic. Did I do that right? Or metal and a polyatomic?
Metal and a polyatomic.
Metal and a polyatomic. I think I said the same one twice.
That's all right.
Okay, we're going to be looking at compounds of nonmetals, and we're going to be looking at only binary molecular compounds, or binary molecular nomenclature, so those are going to be having only two atoms.
Or two elements.
Two elements, sorry.
Two elements. Okay, so when you name binary molecular compounds, which means you have two nonmetals bonded together, you name the first nonmetal, you name the nonmetal furthest to the left of the periodic table first with no changes, and that will be the nonmetal that's written down first. So it's going to be furthest to the left on the periodic table. It'll also be first in the formula. So you just name it. And then you name the nonmetal that's furthest to the right on the periodic table, which will be the second nonmetal. For this, you need to add the suffix IDE. So oxygen, again, would be oxide. Now, if there is more than one of the first element, you need to indicate it. But if, in the case of the second element, you need to indicate how many you have no matter what. And to do this, you're going to be using Greek prefixes.
Okay, so these are the Greek prefixes you need to know. Most of these are ones you've seen before, so it's a pretty familiar idea. But if you have a subscript of 1, you use mono, except for, like Ms. Wolpa said on the first element, if there's only 1, you just assume it's 1. If there's a subscript of 2, it's di. Subscript of 3 is tri. 4, tetra. 5, penta. 6, hexa. 7, hepta. 8, octa. 9, nona. And 10, deca.
And you'll notice in this little table, there's lowercase and capitals. Everything's lowercase when you're using it.
Oh yeah, that's autocorrect.
Yeah, and it's not, that's what I figured. Okay, so what we're going to do here is name some of these. So if you look at the first element, you have nitrogen first, oxygen second. There are 2 nitrogens, 3 oxygens. So you name the nitrogen first, and since there's 2 of them, you write down dinitrogen. And then because there's 3 oxygens, it's trioxide. So dinitrogen trioxide. The next one, there's only 1 carbon. It's the first element, so you simply write down carbon. And then the second is 2 oxygens, so that's carbon dioxide. With the third one, it will be diphosphorus, because there's 2 P's. Pentoxide, because there's 5 oxygens. Now, when you have oxygen, the A in penta is not included because you don't want pentaoxide. There's too many vowels there, so it's just pentoxide.
Okay, so now we're going to be looking at nomenclature of acids. Acids actually will begin with a hydrogen, and if it's a binary acid, it's just going to be hydrogen with 1 other nonmetal. When you name the acid, you're going to begin with hydro, then you're going to add the stem of
That's my dog.
She's barking because it's raining. Okay, sorry. Then you add the stem of the nonmetal plus the IC ending. So just with the other ones, we always did the IDE ending. This one you do an IC ending, and then you're going to end with the word acid.
Okay, so the first one here is hydrogen and chlorine. So it's hydrochloric acid, hydrochloric acid, which I'm sure you're all familiar with. The next one is hydro. Notice you don't have to say dihydrogen because we're talking about an acid here. Hydrosulfuric acid.
Okay, acids that have a polyatomic ion, so these are going to be what we call an oxyacid. They'll be hydrogen plus a polyatomic, have a different naming system. These will not use hydro in the beginning, so hydro is omitted even though it still starts with a hydrogen. you are going to use the polyatomic ion name alone, and you're going to change the ending. So if the polyatomic ion ends with "ate," it will become "ick." If it ends with "ite," it will become "us."
Us. Us. Whatever.
I don't. Us? Hydrochlorus?
Oh yeah, it is.
What do you say?
No, I say us, I guess.
What do you think you said?
I thought I said us. But anyway, you don't use hydro in the beginning of these. Now, unfortunately, the first two the examples that we're giving you are exceptions to the rules. So before we name those two acids, I think we should do a normal
I'll do
one.
it up here.
So we'll do HNO3 and HNO2. So NO3 is the nitrate ion, so this is nitric acid. The NO2 is the nitrous acid, nitrite acid, excuse me.
Nitrite ion.
The nitrite ion. And so this is nitrous acid. Okay, now the two examples that are actually written and typed into the PowerPoint, that's H2SO4, H2SO3. So SO4 is the sulfate ion, so you would think it would be sulfic acid, but it's not. It's sulfuric. So there are a couple of exceptions to these rules. The second one is sulfite, the sulfite ion, but instead of being sulfus acid, it's sulfurous acid. And those exceptions are for the sulfate and the sulfite, the phosphate and the phosphite. Those are the ones that you have weird, but everything else is just the ick acid or us acid.
Whoops. Okay. There's another nomenclature convention, and that's naming a hydrate. And some ionic compounds actually can have water molecules attached within the structure. These compounds are actually called a hydrate and have properties distinct from the unhydrated form.
So hydrates are named by naming the ionic compound they're associated with, and then using a Greek prefix to indicate the number of water molecules followed by the word hydrate. So for this particular hydrate, we have copper 2 chloride. Remember, the copper has a +2 charge because it's with 2 chlorines, and we have to indicate that because copper could be 1 or 2. So it's copper 2 chloride. We have 5 waters, so that's pentahydrate. Now, when these formulas are written, they're written with the ionic compound followed by a little dot and then 5H2O. That is not a multiplication sign. That just indicates that the 5 waters are incorporated into the copper chloride crystal.